Hello everyone, and today we will be seeing one of the problem from Geeks for Geeks. This is a pretty standard problem, and which is kth largest in a string. Now the problem goes like we are given an input string ARR of n integers. Find the kth largest element and not kth largest unique element. Okay, after insertion of each element in the string. If kth largest element doesn't exist, the answer will be -1 for that insertion. And return the size of n, where each element represents the kth largest value after corresponding insertion. Now we have presented with example, and k is 4. Now with k is 4, we wanted to understand what is the fourth largest element when we see just 1. So it is a string. Do not consider it as an array, first of all. And if you can visualize this, consider this as something which you will get in real time. Now if the data is like this, you will first of all see 1, and if k is 4, which is within this example, what is the result you can see? Nothing, because there's nothing fourth element. So yeah, there is then 2. Same goes with 2, -1. There is 3, same, -1. There is now 4. Now with 4, the previous numbers were 1, 2, 3, 4, something like this, 1, 2, 3, 4. And now with 4, you have a maximum kth largest number. And what is the kth largest number? First of all, understand what the largest numbers are. Largest number is 4, then it is 3, then it is 2, then it is 1. So the fourth largest number is nothing but 1. Cool, makes sense. So the answer is 1. Next there comes a number which is 5. So it would be looking like this, 5. And in this case, 5, the largest numbers are 5, 4, 3, 2, 1. So 5 being the first largest element and 1 being the fifth largest element now. So the answer is 2, because 2 is the fourth largest element. So forth it goes for 6, where the answer is 3. How can you solve this? One such thing, you see, you can just comprehend this as like, hey, for each 1 to 1, I'll just sort it out from range. Then I'll take array of 2 and I'll sort it out. Then I'll take array of 3 and then I'll sort it out to understand what is the maximum. Or without any sorting, you can just say that, hey, I'll just parse the array. But even parsing for n ranges, so you will get n ranges from 1 to 1 to 1 to 2, so on and so forth, 1 to n. Then it will give you a time complexity of n log n. Sorry, not n log n, n square. But you don't want to solve this in n square. One such thing, whenever you see that, hey, you want kth largest, kth smallest, and this kind of thing, one thing which should pop into your mind is heap or priority queue. This two data structure are meant for such kind of thing. So heap, if you want maximum, you have a min heap, max heap. If you can use it accordingly, whatever the problem statement is. But how does heap give us a picture over here? Let us try to understand. How can a heap help us out here? So heap has a very beautiful functionality that it gives you the minimum or the maximum element. So what I want is a maximum element, and what kth maximum element. But what if, and if I understood that, hey, kth maximum element, if I took every element side by side, 6, 7. So kth maximum element is nothing but I'm getting, so k is 4 in this case. From this window, I wanted to have the maximum element, which is 1. And 1, for your information, 1 is not a maximum element, 1 is a minimum element. So you want minimum of k window. That's where I'm shrinking the problem a bit. So you don't need to worry about the entire array, but only k window, and you can slide the window bit by bit. So you're just taking a heap into picture and considering k elements, and within the k elements you have to play. Why am I choosing only k elements, you can ask. Yes, that's a very good question. If I'm choosing n elements, then I need to iterate through n elements and get the k. But if I'm getting the k elements only, I just need top element. Cool. And that is where we are. We will take k elements, we will understand the top element, and top element would always give you a value. And once I am sliding this up to incorporate 5, my top element would be 2, and once I go bit further, my top element would be 3. And that is what our answer is. 1, 2, 3, 1, 2, 3. And previously, if I don't find any elements or my queue size is lesser, I will just return -1. Excellent. So that sounds like a plan. Let's start to implement this one. Don't worry, if things are not clear, it would be within a while. So this would be our result. It would be an array list, and we are going to return this one. Return result. The entire thing happens between. We want a priority queue of integers, obviously, and this would be, I'll be naming this as queue, new priority queue. If I wanted to have a size, I'll not prefer having a size, but if I wanted to have a size, I'll limit it to k. But anyways, let's not increase the confusion. I will take elements one by one from an element, I'll say element from A, and I'll just push it into q dot offer, and I will offer this element, and I'll check if q dot size, if it is greater than k, what will I do? I will just pull out of it. That means remove. Why I'm removing this? Because I don't want k plus 1th element. I just want k elements, top k elements, and that's the reason I'm removing extra things. Again, this also serves a size. My size is just limited to k for q at any given point of time. Now I wanted to store the result dot add, but wait a second, I am not adding the result right away. I need to check that, hey, if q size is greater than or equal to k, then only I can get the element within the queue. If not, I'll just return -1. That's what we are asked to. Like from top fourth element, fourth largest element within the array of 1 and 2. There cannot be any because there are only 2 elements. That's what I'm seeing here. If there are only there is equal to k elements, or let's say there are lesser than k elements, then just return -1. You can just remove the logic and use this instead if you like to. Cool. And here it is. Our program is ended. This is it. I like to compile this one for any test cases and compiler errors. There are none. Let's try to submit this one. Interesting. What is wrong here? Your code output is 2, 1. Am I missing something? I don't think so. Oh, I don't need to poll it. I just need to peek it. Why am I removing these things? So let's try to rerun this one. We just wanted to check the element and we don't want to remove the elements, right? And the error came because if I had multiple characters like this, I have removed 2, I don't want to remove 2 again. I just wanted to check what is the top, and that's it. So yeah, this was the problem, and this had a topic tag of heap and data structure. Again, this was a very favorite problem from this all companies, and they respected the time complexity n log k. Although the auxiliary space complexity is O of k, because we have just used O of k size, but O of n, it's okay. It's okay if you are asking. Our space complexity is much better than this. Again, cool. This followed a topic tag of heap, and such kind of problem, whenever you say largest, smallest, kth element, just think once, can this be solved with heap? This is a very good idea, initiative. You can check, implement, and if you wanted to practice more heap related questions, click the video on your right, and I will see you in the next one.